again for a while. And my next speaker, so I've got a few speakers in a row now. My next speaker is also in Cardiff, and he's called Tony Thompson. He's from Thompson STEM Engagement. And Tony's going to talk to us today about the work they're doing with Europlanet and looking for places on Earth that match or potentially match places on other parts and other parts of the solar system. Tony, it's all yours. If you want to share your screen, if you want to come and say hi, there we go. So we see you.
I'll just get that screen share ready.
If you put that into, there you go, that's in presenter mode, you're good to go. I'll stop you in about 18-20 minutes time.
Brilliant, thank you very much, Felicia. Right, as was said, my name is Tony Thompson. I'm the company head and lead developer for Thompson STEM Engagement. I'm joined here today by the soon-to-be Dr. Rosie Kane, just off to the side, who is our head of astronomy.
Tony, you're a tiny bit quiet.
Right, I'll just step forward slightly.
Shout, go nearer the mic or shout.
Yeah,
Cheers.
better?
That's absolutely fine. Thank you.
So we have been developing resources to do with the Planetary Field Analogues sites alongside Europlanet. The Europlanet 2024 research infrastructure provides free access to the world's largest collection of planetary simulations and analysis facilities. The project is funded through the European Commission's Horizon 2020 programme and runs for 4 years, from February 2020 until January of 2024. The Transitional Access programme supports all travel and accommodation costs for European and international researchers to visit 24 laboratory facilities and 5 planetary field analogues. Now, as part of the education and inspiration tasks associated with Europlanet 2024's research infrastructure, we have produced classroom resources aimed at ages about 10 to 14, relating to the conditions found within planetary field analog sites to astrobiology and the habitability of Mars. Now, for those of you who are unaware of what a planetary field analog site is, it is when we find somewhere here on planet Earth which perfectly demonstrates what conditions we may find in locations which are harder for us to access, such as areas on Mars. Now, the field analog sites we have chosen to use are the Rio Tinto River in Spain, the Iceland field sites, the Danakil Depression in Ethiopia, the Kangasat field site in Greenland, and the Mcgad Caddy site in Botswana. And what we've done for these is we have developed 45-minute to an hour long lesson plans. Fully put out PowerPoints. We've also got extensive teacher notes to go along with those, and lab-based video demonstrations to illustrate some of the points given in these analogues. Now, we are looking to link this together to underrepresented areas of astronomy within the curriculum, such as certain aspects of physics, space exploration, and also astrobiology. Let's take a bit of a look at some of these locations. Starting with the Rio Tinto River. The Rio Tinto is a highly acidic environment. For this, we have shown demonstrations to do with changes in pH. Simply enough with that one. For the Iceland field sites, this is a heavily volcanic area. So we've very much gone into some of the geoscience behind volcanism. We've developed 2 videos for this one. One is the formation of the largest volcano in the entirety of the solar system, Olympus Mons, found on Mars. And we've also looked into the chemistry and the physics behind convection. Moving on to the Danakil Depression in Ethiopia, we are looking to take a glance at the history of Mars, or at the very least, how we believe that would have taken place. Now, the Danakil Depression is one of the hottest areas on Earth. And using this, we are looking to show how water may have evaporated from areas that are believed to have had waterways previously on Mars. And moving on to the Kangasat field site. For this, we're looking at the Martian soil chemistry. The Kangasat field site has areas of permafrost. Now, areas of permafrost are found on Mars at the poles. These areas of permafrost contain a lot of solid carbon dioxide, dry ice, So we've got a video developed which looks at the sublimation of dry ice, and also a video which was an experiment that we did here for the purposes of this resource, which is looking at how salts affect the freezing point of water. Now, you may have been made aware that a few years back, there was a study which looked into the possibility of a subglacial lake at the South Pole of Mars. So this demonstration was performed to show exactly what would happen in these high saline conditions, in hopes to get these students thinking critically about whether or not they think this study gives sufficient evidence for that claim. Now on to the Mcgad Caddy site. These are salt pans. So this used to be a saltwater waterway, which over millions of years, this water has evaporated away, leaving denser elements such as sodium chloride behind. Now, we have found metallic salts on Mars. So this contains a video which shows that process with the evaporation of salt water, leaving behind crystalline salt beds. Now, speaking of that, we've also looked at a site which is not part of the Europlanet Planetary Field Analogues sites, the Basque Lakes in Canada. Now, the Basque Lakes are a highly saturated waterway of magnesium sulfate. Magnesium sulfate was found by the Viking missions on Mars. Now, with this saturation, it has left depositions of crystalline magnesium sulfate at the edge of the waterways. So we have looked to demonstrate how supersaturated solutions can leave these depositions. For this, we have used sodium acetate in a supersaturated solution, which when poured out will form a crystalline deposit. We also had a more general look at astrobiology. So we have a lesson plan based on life in extreme environments. Now, with single cellular organisms, generally when they're affected by an extreme environment, it's due to how their cell membrane reacts to that environment. So we have a video in this one which illustrates the concept of a semi-permeable cell membrane, and also some analogues of single cells being exposed to different stresses. We also really wanted to emphasize the linking to the curriculum areas. Of course, these are going to be going out to schools. Some of the underrepresented areas include physics, space exploration, and astrobiology. Now, we do have a bit of a sneak preview of some of this content for you. I am going to turn this down a bit. We have found this video is exceedingly loud. So I've turned that down. Hopefully that should be all right now. So this is a compilation of some of the video content that has been developed for this project. So that's some of the work that's been done for this project regarding Mars. But let's take a look at the future of this project. Next, we intend to do a similar structure with our teacher notes, the scheduled classroom activities, and the videos, but regarding the icy moons of certain gas giants. So this is going to be a lot of sub-zero temperature demonstrations and discussions, linking it back to possibilities of life and habitability once again, looking towards Europa and Enceladus for those. One of the demonstrations we've actually already planned out for this one is looking towards Titan with condensing hydrocarbons such as methane for the lakes of Titan. But for this one, we're going to be using butane and propane to show the effects of condensing those. And with that, that does bring us towards the end. What we do want to emphasize for this, however, is we more than happy to take on any feedback you may have. If you have any suggestions about the Mars project, or indeed the Icy Moons project, please feel free to email us. It's tony@thompsonstem.co.uk, or contact us through Twitter. It's @ThompsonStem. Aside from that, a big thank you for all of you here at the conference around the world, and I hope you enjoy the rest of it. We do have a few more minutes. If anyone does have any questions, that would be fantastic.
Tony, thank you very much. There's not been enough explosions and fire at this conference.
Absolutely not.
It's not a proper conference unless something goes on fire. That's my motto anyway. That's really interesting stuff. You've got a lot of information there, and also hi to nearly Dr. Rosie as well. So from my point of view, the first question I have, I'm just looking to see if anyone else has come up with anything as well. Do you get to travel to these places?
I haven't actually. Rosie, of course, during her research with the UK Centre of Astrobiology, did go to the Basque lakes in order to collect samples and bring those back for her research. I've not been to any of these analog sites. I would love to, but as this project began, so did the global pandemic. So there's not really been much scope as of yet. But one day, I'd love to go and visit.
There's a couple of people saying thank you for the talk as well. They've enjoyed it, and I'm sure they'll be in touch with you. So if you have the opportunity, we've got a few minutes left anyway before the next talk. If you had the opportunity, where's the one place on Earth that you would go to? Ooh. In terms of work now, I'm not talking about going to Las Vegas or...
Yeah, Rosie and I have often discussed Yellowstone National Park. Of course, that was where the discovery of Thermus aquaticus was made, which from a genetics perspective was a massive influence. The development of PCR would have been impossible without that microbe. A huge impact on the concept of extremophiles as well. What was it? We didn't think they could have survived above 50 degrees Celsius before that. And then suddenly we find it in 90 degrees Celsius. And that was a massive development in that field. And of course, it's a beautiful area. It's in a supervolcano. Why wouldn't you want to go there and find out what you could look at and discover? It's also an area of astounding natural beauty. So yeah, Yellowstone National Park would probably be our answer.
I'm wondering if the fact that it's in a supervolcano is exactly why you wouldn't want to go there, but I appreciate the chances of it actually becoming an active supervolcano while you're there are reasonable. Well, it's 2020. It's been that kind of year, so who knows? There was one question, or one comment on here from Kirbal, who said Danakil Depression is a must to visit. Are you aware of that one? Yeah. Yeah,
that is the Ethiopian one that we were looking at.
Oh, that's right. Yeah.
About evaporation for the history of Mars. Yeah, one of the hottest places on Earth. Yes, that'd be nice. I've never even left Europe. Like anywhere would be great.
I'd settle for a visit to England. Well, no, maybe not England. Let's not go that far. Sorry, Rosie. I'm going to keep you going for another couple of minutes because we will start the next talk at 6:15. So the next question, I'm just going to keep firing questions at you. And it's gone. I had a question. Where in the solar system do you think we're going to find? Okay, it's a loaded question. Part one of the question: do you think we'll find life at some point, or evidence of previous life in our solar system? And if so, where do you think we should be looking?
In our solar system, I would argue that our best bets would be Enceladus. There was a study a couple of years back which it seemed that they detected molecular hydrogen coming out of cracks in Enceladus, which could be a marker for hydrothermal vents at the bottom of the seas. And we know here on Earth, hydrogen sulfide gas, very good as a source of energy where you can't get sunlight. So everything is there on Enceladus for the potential of life. But of course, life is such a random happenstance of things that it's anyone's guess, really. I know that Rosie quite likes Enceladus as an. Oh, I said Enceladus. You said Europa. That's it. Getting confused there. Don't glare at me. Yeah, Europa is what Rosie would usually say for that. But of course, evidence of previous life, Mars is a possibility. I mean, it is looking more and more likely that there definitely was waterways on Mars, and from an Earth-centric perspective, where there's water, there's life. So that is certainly an option. Going a bit further field than that, I would argue, by the sheer size of the universe, I personally don't think we're alone. Whether or not it's in our solar system is a very different question. But if it's further afield, I'm not sure that humanity would ever encounter it if we'd last that long or find a way of traveling that far. So I don't think we're alone. I also don't particularly fancy our chances of finding anything, at least of all complex life. We're far more likely to find microbial life within our solar system.
Sure. I guess it's just simpler to find it. We're so much closer to these bodies like Enceladus and Europa. Tony, I think we're going to leave it there. I've kept you on the spot for long enough, but I know hopefully people were fascinated by your insight into that, and they'll be in touch with you and Rosie about your work. Thank you very much.